Hi guys, so today we're going to be doing the area of composite figures. And before we get started, let's talk about what a composite figure is. So a composite figure is a figure that can be separated into regions that are basic figures. Okay. So for example, here this is a composite figure. It is composed of several different shapes, right? It's composed of this triangle up here, and this square, right? And so to find the area of this, instead of finding the area of this weird shape, what we can do is we can find the area of a triangle and this triangle, which is a little bit easier, and the square, and then add it all up together, okay? And that's basically what this postulate says. The area of a region is the sum of the areas of all its non-overlapping parts. Okay, so let's get started with our first example. Okay, so it asks us which is closest to the area of this composite figure. Okay, so what we can see here is it's composed of several parts, right? It has this weird looking shape here, and then this semicircle, right? And so what we can do to find the area of this is we can find the area of, this is almost like a rectangle. We can find the area of the rectangle, right? And the area of this semicircle, half of our circle. And then note though that we didn't do the whole rectangle. We're taking out this small part here, which is similar to a triangle, and we can subtract the area of that triangle. Okay. So let's get started. So area of this rectangle here, this is 19, this is 6, so the area of the rectangle would be 19 times 6. So 19 times 6. Okay. Then the area of the semicircle, so this is half of a circle, so it's going to be half of pi r squared. So half of the circle, so half pi r squared. This here says that it's 6, so from here to here, this is 6. That's the diameter. We want just the radius, so half of 6 is 3, so 3 squared. Right. And now this triangle, okay, it gave us a zoomed in picture of this. Okay. So note, it's claiming that this is an equilateral triangle, right? Because 6, 6, this is 6 here, right? And then we can split it, right? 60 degrees, 60 degrees, 60 degrees. This splits it. So this is 60 degrees, this is 30 degrees, this is 90 degrees. Okay. The short leg here is 3. So this height here for my triangle is the long leg. So that'll be 3 square root of 3. So minus area of the triangle is 1/2 base times height. Base of triangle here is 6. And then the height of triangle, which is this here, right, it's the long leg of this smaller one, smaller of this 30, 60, 90 triangle, so this is 3 square root of 3. So now let's simplify. So 19 times 6 is 114. 3 squared is 9, so 9 half pi. Right. Half of 6 is 3. 3 times 3 is 9, so minus 9 square root of 3. Okay? So then when we're entering it into the calculator, make sure you enter it correctly in. Your calculator does not know order of operations, so you need to use correct parentheses and stuff like that, so that way it knows what to do in what order. Okay? And then as a result, I got 112, this is approximately 112.5487. Which one is it closest to? Right here, A, 112.5 units squared. Okay. So why don't you try CYP1, and then once you're done, come check your answer. Okay, you should have gotten G. If you got that right, you can move on to the next example. If not, here is your explanation. Okay. So this figure is kind of composed of a triangle and a rectangle, but without this part of the rectangle, which is kind of like a circle. Okay, So to find the area of this composite figure, I'm going to do the area of the triangle plus the area of a rectangle, and then I'm going to subtract this portion of a circle. Okay? Area of a triangle is 1/2 base times height, so base 10, height 3.5. Okay? This rectangle is length times width, or base times height also, so 10 times 5 for the rectangle. And then this circle is about 1/4 of a circle, so I did 1/4 of the pi r squared. Pi, and then here, since this is 5, this is also center to here. That's 5 as well, so the radius is 5 squared. Okay. Half of 10 is 5. 5 times 3.5 is 17.5. 5 times 10 is 50. And then 5 squared is 25. 25/4 pi. Okay. Entered that all into my calculator, and I got approximately 47.8650. And that rounded would be about 47.9 squared. Okay, so now let's move on to example 2. So Melissa's dining room table has hardwood around the outside. So you see the table here has this wood on the outside. Okay. We want to find the area of wood around the edge of the table. So basically, what we're given, okay, is that these are 10. How long it is 3. Okay. And then here we have like 4 parts, okay, that are these little circles, which this is zoomed in, right? It's rounded here, okay, and so then it looks like this where the radius is 3, okay. So essentially the wood edge is the area of the different rectangles plus the rounded edges. Okay, so let's start with the area of the rectangles first. That's a little bit easier. So this one has a length of 60, and we know the edge is 3 inches long. Okay, so then it would be 60 inches times 3 inches. Okay, and then because there's 2 of them, there's one here and there's one here, I'm going to multiply that by 2. Then, doing this edge and this edge here, this is a length of 40, and again, the edge is 3 inches long, and there's 2 of them, one here and one here. So that will be 2 times 40 times 3, okay? And then, the next part is the circle, the rounded edges here. So since there's 4, these 4 quarters put together make a whole circle, okay? And then since we know that the edge is 3 inches long, that's the radius. So that would be pi 3 inches squared. Okay. So then let's simplify it. 2 times 3 is 6. 6 times 60 is 360. Okay. 2 times 3 is 6. 6 times 40 is 240. And then 3 squared is 9, so plus 9 pi. 360 plus 240 is 600. So 600 plus 9 pi. And so I'm going to do 600 plus 9 pi. And that gives me approximately 628.2743, right, which the book rounds to 1 decimal place. So that's why the book says it's 628.3, and then with all the area, that inches times inches gives me square inches. There we go. Okay. So why don't you try CYP2, and then once you're done, come check your answer. Okay, you should have gotten 40.6 square inches. If you got that right, you can move on to the last example. If not, here is your explanation. Okay. So this birdhouse, it's a pentagon here, but because it's not a regular pentagon, we can't use our whole 1/2 perimeter apothem thing. Okay, but instead, this pentagon can be split up into a triangle here, and then this kind of rectangular base, and then we take out the circle for the hole for the bird. Okay, so to find the area of the part he has to paint, that's area of the triangle part plus area of that rectangle part minus the circle for the hole. Okay, so area of triangle is 1/2 base times height. The base here is 6.5, okay? And then the height, this whole thing is 9 and this part is 5, which means that this part here, the height of the triangle is 4. Okay, 9 minus 5. Okay. Then the area of this rectangle part here, that's base times height or length times width. Okay, so that's 6.5 times 5, so that's the rectangle part. Okay. And then the circle has a radius of 1 1/4, so minus the circle, so pi r squared, so minus pi 1 1/4 squared. Okay. Half of 4 is 2, 2 times 6.5 is 13. Okay. 6.5 times 5 is 32.5 or 32.5. Okay. 1 1/4 squared is 1.5625, and then times the pi. And type this all into my calculator. I get 40.5913 something something something, and then it asks me to round to the nearest tenth, so that's about 40.6 square inches. Okay, so moving on to our last example. Okay, so this is doing the same thing, but we're finding the area of it on a coordinate plane. Okay, so this they're going to make it pretty easy with things that you can already find the area of. If you have not, if it's an unusual shape, we have a way of finding the area of this using something known as the shoelace method. But here, since they're going to break it up into nice pieces for us, I think we're okay. Okay. Okay, so here we're finding the area of this composite figure. And what we see here is we kind of have this trapezoid looking thing. So this is one of them. Okay. And then we have a triangle. Choose this part here. Okay. So to find the area of this, that's what I'm going to do. Okay. Another way you can do it is you can make a bigger rectangle and subtract the parts you don't want. That works as well. Okay. But here we can just do it with the trapezoid and this triangle. So we're going to do the area of the triangle plus the area of this trapezoid looking thing. I know it doesn't look like this, but that way I know it's a trapezoid. Okay, so area of a triangle is 1/2 base times height, so 1/2. The base here is here to here, the -3.7 to 3.7, and that is 1, 2, 3, 4, 5, 6 units long, so 1/2 times 6. And then the height, remember you want it to be perpendicular, so here, this is the height that you're looking for, and that's 1, 2, 3. Okay, so that's area of the triangle. Plus area of the trapezoid is 1/2. Okay, we need height again, so then remember it has to be perpendicular, so 1, 2, 3, 4, 5, 6, 7. And then base 1 plus base 2. So this is base 1, this is 6. And then base 2 here, if you count 1, 2, 3, 4, 5, 6, 7, 8. And there you go. Okay. Now we're just going to simplify. Half of 6 is 3. 3 times 3 is 9. Okay. 6 plus 8 is 14. 14. Half of 14 is 7. 7 times 7 is 49. And then 9 plus 49 is 58. So it is 58 square units. There you go. All right. So the other way I was talking about is that you could have found the area of this whole thing, which sometimes this works really well, and then you subtract all this part, and this part. Okay, so that's another way you can do it. Okay, so why don't you try CYP3, and then once you're done, come check your answer. Okay. You should have gotten approximately 26.3 square units. If you got that right, you can get started on your homework. If not, here is your explanation. Okay. So this area of the composite figure, it's composed of a semicircle, a square, sorry I drew it like a rectangle, a square, and a triangle. Okay. So to find the area of all of it, I just need to find the area of each of the pieces and add it up together. Okay. So semicircle is half of a circle, so that's why you see the half pi r squared. The diameter is 4, which means the radius is 2, so 2 squared. Right. Then the square is just base times height, length times width. Right, so this is 4 and this is 4, so 4 times 4. Okay. And then the triangle is 1/2 base times height. So base is 4 here, height is 2, so 1/2 4 times 2. Okay. 2 square is 4. 4 divided by 2 is 2, so 2 pi. 4 times 4 is 16. Half of 4 is 2. 2 times 2 is 4. Okay. Then enter this in, get something like this, and then I rounded it to 1 decimal place, so 26.3. So that's it for today. Have a great rest of the day. Bye, guys.